Greetings. So this is the first part of the AWS AI Practitioner question and answer analysis. What we're going to do before we get started is let you know that you should like, subscribe, share this with anyone you know who might be taking the AWS AI Practitioner. You can also see some of the other exams in the playlist and find some useful information if you're in cloud, cloud security, DevOps, DevSecOps, or any IT profession and are looking to enter the cloud. So what we're going to do is get started. All right. Okay. What is one of the primary advantages of using generative AI in the AWS cloud environment? Answer: generative AI can automate the creation of new data based on existing patterns, enhancing productivity and innovation. So why is this correct? This is correct because generative AI models like those used in AWS Bedrock are largely trained on data sets to understand patterns and generate new outputs such as text, images, code, and more. This helps accelerate innovation and content creation, automate repetitive tasks, and empower developers and businesses. So what could we use as far as a resource? Let's see. All right. So this would be one primary resource you could find here. All right. Why is this going to be useful? You can see Bedrock, SageMaker, Titanium, and all the applications you can use for this. Okay. All right. Okay. So why are the other answers incorrect? So generative AI can ensure 100% cyber threats? No. I mean, it can help with it. You can use machine learning to spot anomalies, but no system can guarantee 100% protection. Replace human roles? I mean, it can augment it, but not replace it. So it can generate code or assist in tasks, but it can't do deep critical thinking or design, or it doesn't have the full domain knowledge needed for the full SDLC. Perform cloud maintenance tasks. So while it can automate parts of maintenance like predictive scaling or log analysis, full autonomy without humans is pretty unrealistic due to governance, compliance, error handling, and a bunch of other necessities. Okay. Next question. A manufacturing company aims to leverage Bedrock to create a generative AI application that automates the monitoring of inventory levels, sales data, and supply chain information. The application should also recommend optimal reorder points and quantities to enhance operational efficiency. So the correct answer is B, agents for Amazon Bedrock. All right, so why is this correct? So agents are designed to automate multi-step tasks using foundation models. In this case, the company needs a Gen AI application that not only monitors data, but also recommends actions, such as optimal reorder points. This is a perfect fit for agents. So agents can autonomously reason, use APIs, invoke business logic, return results, and have business-oriented responses. And so behind the scenes, AWS will manage all of it. All right, and oh, my source doesn't exist. All right, so this would be a good source to go in for this. All right. So here's some information that can show what agents can do to perform this, fulfill customer requests with all of that. All right. All right, so why are the other answers incorrect? So watermark is only used for Titan image generation, right? So it's unrelated to business processes. Let's see, knowledge bases. These are used for RAGs, the retrieval augmented generation. So it provides context to foundational models from private sources. So it's useful for enhancing agent responses, but knowledge bases do not perform actions or automate themselves. And then guardrails are designed to filter outputs. So this enforces responsible AI policies and blocks harmful content and redacts sensitive information like PII or PHI, but they don't automate tasks or business logic execution. All right. Next question. Which of the following generative AI techniques are used in Amazon Q business web application workflow? So RAG and LLM. So why is this? So RAG is a foundation model, or it lets a foundation model reference up-to-date external data, like internal business knowledge at inference time. So it makes responses more accurate and relevant. And it extends the LLM with access to a live or recent data store. So it eliminates the need for retraining the model to incorporate recent business data. And then the LLM. So Q Business uses LLMs to process and generate human-like text summaries and answers. So examples would be conversational question and answering, summarization, or classification, right? And so it can all be powered by your foundational models. All right. Let's see if we can. Okay, so this is a Gen AI overview of what this can do. accelerates research, customer experience, but you'll probably get more information about why the other ones are incorrect. So what are variational autoencoders? So these are used in image and latent space modeling. These are not for conversational AI or knowledge retrieval. So they don't really apply to Q business. And GAN, generative adversarial network. Okay, so this is used for image, video, and audio synthesis, not natural language processing. So it's not part of the architecture or components in Amazon Q. And then diffusion model, so that's related to high fidelity images. So this can be useful for adding or removing noise from images. So it's not used for language tasks or business workflow automations in Q business. All right, next question. An e-commerce company is transitioning to AWS Cloud and wants to use Bedrock for product recommendations. The company wants to provide its own labeled training data set to improve the selected foundation model's performance. Which of the following represents the best fit solution? Leverage Bedrock to make a separate copy of the base foundation model and train this private copy of the model using the labeled training data set. So why is this correct? So Bedrock supports fine-tuning of foundation models by making a separate private copy of the base model. So your labeled training data can be used to customize the model more securely, and your data never modifies the original base foundation model or becomes accessible to other users. So some things included would be the infrastructure doesn't require any additional management, so lower operational overhead. There's custom fine-tuning, and the private copy ensures data isolation and compliance. And then you're also given encryption in transit and in rest, which is optimal using AWS Private Link. All right, let's see. You can see, let's see. Fine tuning. Okay, so you can experiment with the top FMs, customize them with your private data using fine tuning and RAG. All right, so why are the other answers incorrect? We'll see if we have this. Nope, this link no longer works. That's okay. All right, so the other answers, why are they incorrect? So use Bedrock to make public copies. Well, okay. Bedrock does not allow users to make public copies of foundation models. All fine-tuned models are private. Bedrock to discard the selected foundation model and create a new model. So Bedrock does not support model creation from scratch. For that, use SageMaker. Okay, and then use Bedrock to train the base foundation model itself. So you can't modify or retrain the base foundation model. Bedrock only supports fine-tuning a copy of the model within your account. All right. So next question. What's a key difference between labeled and unlabeled data in the context of machine learning? So labeled data is annotated with output labels that provide specific information about each data point and is used for supervised learning, whereas unlabeled data lacks such annotations and is used for unsupervised learning. All right, what does this mean? All right, so labeled and unlabeled data are foundational concepts in machine learning. So labeled data includes input data paired with correct outputs or annotations. So it's used for supervised learning. So you can think of an example of an image with an object type like a cat or a car, and a sentence with a sentiment like positive or negative. Or then you can have emails that can be labeled spam or not spam. Whereas unlabeled data contains only the input feature with no known output. So it's used in unsupervised learning for tasks like clustering or dimensionality reduction. Okay, and let's get some supporting information. Okay, so this is useful for data labeling, right? What is data labeling right here? Let's see. All right, maps an algorithm to input to one output for supervised learning to work, right? And you can continue on with that. All right. All right, both algorithms input and output, predetermined outputs. And you can see an example here how it deploys the model, supervised, right? And so this should help you. All right, so why are the other answers incorrect? All right, so label data can only be used for unsupervised learning, algorithms. Well, okay, so this is completely reversed. So label data is used in supervised learning, and unlabeled data is used for unsupervised learning. Okay, so label data consists of raw information with no tags or annotations. All right, so this inverts the definitions. So labeled data includes tags or annotations, like labels, while unlabeled data doesn't. And then labeled data is inherently more complex to process due to the lack of structure. So labeled data is easier to use in training because it provides guidance for the model. Unlabeled data is harder to process as it requires the model to infer patterns without labels. Okay. Next question. All right. Which AWS feature or service offers a choice of a high performance foundation models and the ability to privately customize the FMs with their data? This is Bedrock. Okay, so why is this correct? So Bedrock is a fully managed service that provides access to a choice of top performing foundation models from multiple providers like Anthropic, Meta, Amazon, etc. Right? So the benefits of this are that you can privately customize your model using your own data without modifying the original foundation model. And it supports techniques like fine tuning, like RAG, the retrieval augmented generation. And there's no infrastructure to manage. So it's serverless, it's scalable, and it lets you build Gen AI apps pretty quickly via the API. All right. Okay. So here's okay. So here's where you can find more information. The model customization is a process of training data to your model to improve its performance. There we go. Okay. And then it goes in guidelines for model customization and provides more. So why are the other answers incorrect? Okay. Okay, so Q Developer is okay. So Q Developer is a Gen AI for software developers. So it can suggest code, answer tech questions, technical questions, and assist with development workflows, but it doesn't allow model selection or foundational model customization. Q and QuickSight. So this is used for business intelligence. So it creates data viz tools data viz using tools like QuickSight. So it's not for model selection or training. An AWS Inferentia is a hardware accelerator. So this is good for inference workloads, not services or selecting or customizing foundational models. So it improves inference costs and performance on an EC2, but it offers no model level APIs or customizing interfaces. Okay. All right, next question. The marketing department at a retail company is working on a campaign for the upcoming Thanksgiving holiday. The department wants to exclude competitive brand names or sensitive topics from the content produced via Gen AI prompts. What type of prompting technique does the given use case present or represent? Negative prompting. Okay. So negative prompting is a prompt engineering technique where you instruct the Gen AI to avoid specific words, topics, or behaviors. So it's ideal where content safety, brand reputation, or compliance is a concern. So this would be like, editing or excluding competitors' names, or preventing sensitive information from getting out, or keeping all the outputs aligned with the marketing or legal guidelines. All right. And let's see. All right. Mm, let's see if I can find this. All right. So negative. Um, so this is components of a prompt. So this would be useful. Hmm. No, this wouldn't have a good one. Okay, maybe we can infer from the other ones. Okay, so let's see. Few shot prompting. So this is a solution that provides. So for this one, you have to provide a few examples of how the task should be performed. So it's a guide for the model's behavior through positive demonstrations, not to exclude or restrict content. Chain of thought. So this is used to improve the reasoning in complex tasks by breaking them into intermediate steps. So it's helpful in logic-based outputs, but doesn't really address content restriction. All right. And then zero shot. So zero shot asks the model to perform a task without any example. So it relies solely on the model's pre-trained knowledge. So that's not really an output dependent. So it does not involve the negative constraints or filtering. Okay. All right, next question. Which of the following are correct statements regarding AWS global infrastructure? Which are two, okay? And that would be each region consists of a minimum of 3 availability zones. Each availability zone consists of 1 or more discrete data centers. Okay. So yes, AWS has has a high standard for reliability and availability. So all new AWS regions since early 2020s have a minimum of 3 AZs. And then the AZs are isolated from one another to prevent failures from cascading, but they're connected via low latency networking, so that allows for highly available architecture and infrastructure. And so you can see here some information on this. Okay, 117 availability zones and then 13 geographic regions, and then announced plans for 13 more. Okay, and you can see all of these listings. It's a lot. It's a lot. And then you have all these edge locations. Yeah, it's a good amount. Okay. And then you can see what South America. That's not as much as you think. Okay. So why are the other ones incorrect? That usually can help. Okay. So each region has 2 or more edge locations. Okay. So, all right. Edge locations are part of the CloudFront infrastructure, not the core AZ design. So regions consist of availability zones, not edge locations. Edge locations are associated with CloudFront. Each availability zone consists of 2 or more discrete data centers. Okay, so some AZs have, okay, so some AZs will have multiple data centers, but it's not guaranteed. So the correct way to say this would be 1 or more discrete data centers, right? So it's a subtle but important difference. Okay. And then while historically, let's see, AWS region consists of minimum of 2 AZs. Okay, so while that was true, because you kept up with the AWS blog, you know that they added and require 3 AZs in new regions to enhance fault tolerance and availability. So the minimum today is 3 AZs. All right, and let's see if we can find this article. Nope, golly. So many of my links are dead. My apologies. All right, next question. Okay. Which of the following is the best fit to create, train, test, and validation splits on your data for machine learning? So, SageMaker Data Wrangler. Okay. So SageMaker Data Wrangler is a visual interface, and it has built-in transformations for preparing data sets used in machine learning workflows. So one of its capabilities is training, testing, and validation splits, right? Which is essential for supervised learning. So it's a no-code user interface. And let's see if we can get the overview. Okay. Okay. Let's see. Train. All right. Training models for data flow. And you can go through here. Yeah. And you can find all the information here. Update it, and you should be good to go. All right. So why are the other ones incorrect? Okay. So ground truth. So ground truth is used for data labeling. That's the human intervention, not data set splitting. So it helps create labeled training data sets using human annotation or automated methods. That's where you get like the third party, the Amazon Marketplace, or Mechanical Turk. SageMaker clarifies. So this is focused on model explainability and fairness. So this is analyzing models after training, not during data preparation. So think about the workflow for those models. And then SageMaker Feature Store. So this is a centralized repo for the machine learning features, right? So it's used to manage and share features across teams, not for data splitting. Okay. All right. Next question. Which is the default vector database supported by knowledge bases for Bedrock? Okay. OpenSearch serverless vector store. Okay. So Bedrock's knowledge base features RAG, which is, retrieval augmented generation. And so it ingests a lot of unstructured data like documents, and it converts them into vector embeddings and stores them in a vector database for fast search, right? So by default, if you don't bring your own vector store, Bedrock can create a vector engine using OpenSearch serverless, right? So this integration is managed by AWS, it's scalable and secure. And so you can also connect it to Pinecone, Pinecone, Redis. You can connect it to Redis Enterprise, right? But those are optional and not default. Okay, so OpenSearch is the default. So why are the other ones incorrect? Let me see if I can find this one. Golly, I'm getting all these old ones. Oops. Okay, so Aurora. So Aurora is a supported option, but it's not the default. Aurora is a relational database, and its use in vector storage. It requires a very specific setup. So remember, there's default stuff, and then there's optional stuff that you can use for different types of search. It's usually cost or operational efficiency will determine it, but AWS has their preferred ones. So you need to configure Aurora manually as a knowledge-based connection. Reddit Enterprise. So Reddit is supported as a third-party vector store, but you must bring your own Redis instance and connect it. So it's not provisioned by default. And then MongoDB. So it's similar to Redis, right? So this is an optional supported, right? It's not the default. And Bedrock does not auto-provision MongoDB. Okay. And next question. Which of the following AWS services powers Amazon Q Developer? Bedrock. Okay. So why is this correct? So Q Developer is a Gen AI powered assistant designed to help developers build, understand, and operate AWS apps, right? So it can answer questions about AWS resources, the architecture, best practices, support issues, and it's tailored to your account and context, right? So Q Developer is powered by Bedrock, which provides access to foundation models from all the providers you can think of. And it handles the underlying foundation model orchestration, the prompt engineering, the security, and the scalability for Q. Okay, so why are the other ones incorrect? So SageMaker, Jumpstart. Okay, so this is a pre-trained model. It's a feature that's a pre-trained model, and it's a machine learning solution, but it doesn't power Q Developer. So it's more relevant for like a data scientist deploying machine learning models via the notebooks or Studio. So it's not for building conversational tools like Q. And then Q Apps. So Q Apps is a feature within Q Business that allows business users to create light web apps, right? So it doesn't power Q Developer, and it's targeted at different business workflows. So it's like an end result after Q, right? And then Kendra. So Kendra is an intelligent search service that uses natural language processing to search and return relevant answers from documents, content, whatever. So it's not a generative AI foundation, and it doesn't power Q Developer. So learn your models, learn your tools. Okay, so next question. Which SageMaker service aggregates and displays data from SageMaker models, model cards, SageMaker model monitor, and SageMaker endpoint services? So this is a SageMaker model dashboard. Okay, so model dashboard is a centralized unified view of all the deployed models in your AWS account, right? So it pulls in and aggregates metadata and insights from the model cards, SageMaker model monitor, SageMaker endpoints, right? So this helps your machine learning team, your model risk manager, your business stakeholders monitor and govern the lifecycle from a single interface. Think of it as security hub, but for machine learning. So why are the other ones incorrect? Okay. So Data Wrangler is used for data prep and feature engineering. And then SageMaker Feature Store, it's a repo for storing machine learning features used during training. So think of it as your repo or your artifact holder. And then SageMaker Jumpstart is an endpoint, is a next knock-on. So it's built to accelerate machine learning development by providing access to pre-trained models and templates, but it doesn't track or display any model performance or monitoring data. Okay, next question. In context of the shared responsibility model for AWS Cloud services, which of the following best describes the division of responsibilities between the customer and AWS? AWS is responsible for security of the cloud, including infrastructure, hardware, and software, while the customer is responsible for security in the cloud, including data, applications, and access management. You need to know this. All right, so the shared responsibility model is a core concept of AWS Cloud security. So think about this. The AWS is responsible for security of the cloud, which means like the physical security of data centers, the hardware, the networking, all that OSI level physical infrastructure stuff and global infrastructure, and then a managed service platform, software, and regions. Customers are responsible for security in the cloud. Okay, so that means the data encryption, classifications, integrity, the IAM, operating systems, apps, network configurations, and then client side and server side security controls. All right. So why are the other one questions incorrect. Other answers incorrect. So customers are responsible for. Okay, so this is so this flips it. All right. So AWS is responsible for security of data centers. Customers never have physical access to AWS infrastructure. They manage, IAM. That would be the data access that you would worry about. And then the next one, AWS is responsible for configuring and managing security settings. No, so this inverts responsibilities again. So AWS manages the underlying infrastructure while customers figure out the applications and security settings. And then C, AWS handles all security aspects, including data encryption. Nope. So AWS does not manage customer-side encryption, IAM, or applications. These are the customer responsibilities in the model. All right. All right. A company is using Bedrock and it wants to regulate the number of most likely candidates considered for the next word in the model's output. Which of the following inference parameters would you recommend in the given use case? Top K. Okay, so top K is an inference parameter that controls the number of most likely token candidates the model considers at each generation step. All right, so when the top K is 1, the model becomes very deterministic and always chooses the most likely token. But when it has a higher value, so like let's say the top K is 50, all right? So let's say very deterministic, but when it's 50, this amount lets the model sample from a larger number of likely tokens. So it increases the randomness and diversity. So this is useful if you want to have creativity versus control and limit the candidate tokens that are eligible for selection. All right. So why are the other ones incorrect? Okay, stop sequences. So these define when the model should stop generating output by identifying end token patterns. So they don't regulate the number of tokens considered, only when the stop output generation. And then top P, okay, so top P controls the cumulative probability threshold for a candidate, right? So instead of the fixed number of tokens like in top K, this lets the model choose from a dynamic pool based on the probability mass, right? So you think like 90% of the tokens. So it focuses on the probability thresholds, not the quantity. All right, and then temperature. So temperature is the randomness or creativity, right? So if you have a low temperature, like 0.1, it's going to be much more deterministic. But if you have a higher temperature, like 0.9, it's going to be more creative. So it doesn't control the number of tokens considered, just how randomly they are selected. All right. Next question. So a company needs a large, high quality and labeled data sets for training its machine learning models. Which SageMaker service helps build high quality training data sets? Ground Truth. Okay. So Ground Truth is the recommended service for building a high quality labeled data set. So it uses a combination of human annotations and machine learning to create scalable, accurate training data pipelines, right? So this uses a lot of manual and automated labeling workflows, and it lets you use stuff like Mechanical Turk, which is like that public workforce. You can use a private, like your own internal workforce, or you can use like a third-party vendor from the AWS marketplace. So this supports like built-in tasks and types for image classification, object detection, semantic segmentation, and a bunch of different things, right? And then the output data can be directly used to train models in SageMaker. All right, so why are the other ones incorrect? All right, so SageMaker Canvas is a no-code machine learning platform for business analysts, right? So you'd use that and wind up spitting that out to something like QuickSight. SageMaker Jumpstart. So this is used to work with pre-trained models and solutions templates. Like this is not a data labeling solution, okay? And SageMaker Feature Store, that's your artifact, okay? So this is where you have your features, so your process data inputs, and then this is not for raw data labeling or data set creation. Okay. All right, next question. Company wants to implement fully managed support for end-to-end RAG, retrieval augmented generation, workflow, and Bedrock. What do you recommend? Knowledge bases. Okay, so knowledge bases for Bedrock is the fully managed RAG. So it lets you connect the private company data sources like an S3 or something on-prem, convert the unstructured, well, I don't know, on-prem. So you can convert the unstructured documentation or data into vector embeddings. You can store them in a vector database like OpenSearch, and then you can let the foundation models retrieve the context of runtime. So this is like the purpose-built solution for any company that's going to use the Gen AI applications that require up-to-date responses. And then why the other ones incorrect? So Bedrock, guardrails. So guardrails enforce safety and compliance, right? So this is a filter policy. Um, it blocks like harmful output, like, think expletives, think PII, PHI. So it doesn't support RAG or dust document ingestion. Watermark. So this is used with Titan image generator. So it identifies any AI generated images to help with transparency or misinformation. So that'll be very useful when you see people doing deep fakes or something like that. So it has no role in document retrieval or LLM or language model context. And then continued pre-training in Bedrock. Okay, so pre-training helps a model learn from unlabeled data to improve domain familiarity. However, it's a fine-tuning method, not a retrieval-based augmentation like brag, right? That's a different mechanism and a different outcome and a different input that they're looking for. Okay. All right. What are the constituents of a good prompting technique? This is saying instructions, context, input data, output indicator. All right. Okay. So a good prompting technique in Gen AI is not just about giving the model a question. It's about structuring your prompt to guide the model, right? You want to deliver an accurate and useful response. So AWS has the four main components is like, all right, instructions. What is this? You tell the model what task it should perform, summarize, classify, generate. Then you have the context, right? So provide the background knowledge or external information to improve it. And then the input data. So this is the actual data. It could be tables, data sets, CSV documents, JSONs, whatever, that you want the model to respond to or process. And you have your output indicator. So this is like what type of response do you want? You want like a JSON, you want a bullet list, you want paragraphs, whatever. So that is where you go. Okay, so why are the other ones incorrect? Okay, so hyperparameters. Okay, hyperparameters. This would be the learning rate or the model size. This is a training time setting. It's not a prompt component. So it's not provided at inference. Instructions, all right, hyperparameters. Again, hyperparameters is not useful with the prompting, okay? This is to configure the model before you even do the training. All right, oh, I'm sorry, during the training, not during the prompt. And then instructions, parameters, input, output. Okay, so, okay. So parameters, something like, the model parameters, like the weights, this is internal to the model. So it's learned during training. So you don't specify them in the prompt. So this is part of the model architecture and behavior, not the user level control. All right. Okay, which of the following are examples of supervised learning? Okay, linear regression and neural network. Okay, so why is this? Okay, so linear regression is a classic supervised learning algorithm. So it predicts a continuous output variable based on the input features. So think like predicting housing prices from the square footage, the age, the number of bedrooms, et cetera, right? So this is a model trained on labeled data. This is the inputs with the known outputs, right? And you have the neural network. So the neural network is supervised learning algorithm. So this is trained with labeled data, right? So they perform complex predictions and it learns patterns through multiple layers, right? Like image recognition, sentiment analysis, et cetera, right? So it's a supervised application that has recognition from labeled images, okay? That would be an example of what it could do, all right? So why the other one's incorrect? So document classification, it can involve supervised learning, but what but this is more of a semi-supervised learning. So it'll use like a small set of labeled data with large sets of unlabeled documents. So this kind of blends supervised and unsupervised. So it's not very clear. All right. Associated rules. So this is unsupervised. This is unsupervised learning. Okay, so this would be a relationship that this would go for looking for the relationship or correlations in data sets, right? So think about when you're going on a website, you see customers who bought this, bought that. You bought shoes, you probably bought socks. So it's usually used for like market basket analysis. And then clustering. All right, so clustering is unsupervised. So it groups data based on similarity without using any labeled outputs, right? So this would be like types of network traffic or customer segments. So it's very broad. All right. And then next question. Which of the following summarizes the differences between model inference and model evaluation in the context of Gen AI? All right. Model evaluation is the process of evaluating and comparing model outputs to determine the model that's best suited for a use case, whereas model inference is the process of a model generating an output, a response, from a given input, a prompt. All right, so why is this correct? All right, so in Gen AI and in the general workflow, so like inference is the act of generating an output, like an image, a text, prediction, right, from a training model, given a specific input, like the prompt. And then evaluation is the process of comparing and analyzing these outputs, usually across multiple models and configurations. Okay. So with this, you can assess the performance and determine which model best suits the use case. So something like Bedrock or any other service, these definitions would be used to clearly separate the runtime behavior from, like the inference from the quality, meaning the evaluation. All right. So why are the other ones incorrect? So both model and inference refer to the process. Okay. So only the model and evaluation involves comparing outputs. Inference is about generation, not assessment. The model inference is a process of evaluating and comparing model outputs to determine the model is best for your use case. Well, okay, so this reverses the definitions. So inference is about generating output. Evaluation is about assessing the output. Okay, and then both model inference refer to the process of model generating. Okay, so this is incorrect because only the inference performs this. Evaluation is comparative and analytical. All right. All right. Next question. So which of the following is correct regarding foundation models in the context of generative AI? So foundation models use self-supervised learning to create labels from input data. However, the fine-tuning of a foundation model is a supervised learning process. All right, so why is this correct? So foundation models like LLMs are trained using self-supervised learning. So a technique where the model learns from unlabeled data by generating pseudo labels from patterns within the data itself. So it can do stuff like predict the next word in a sentence. It can mask and reconstruct missing text. It can learn image text relationships without external labels. So this lets the foundation model scale across massive data sets without manual labeling. On the other hand, fine-tuning a foundation model for a specific task like a sentiment classification or a legal summarization is typically done using supervised learning with explicitly labeled data sets. So this would guide the model to specialize in a domain or some task-specific behavior. All right, so why are the other ones incorrect? So foundation models are supervised learning. Okay, so this reverses it. So foundational models are self-supervised and fine-tuning is supervised. Okay. Foundation models are supervised learning. Okay. Okay. So foundation models are not trained initially using labeled data. That'd be supervised learning, right? So their pre-training uses self-supervised techniques, which we've talked about. And then foundational models are self-supervised learning to create labels. Okay, so pre-training is self-supervised, but fine-tuning relies on the labeled data sets. So it makes it supervised, right? So it kind of twists it a little bit. All right. Next question. Which of the following is correct regarding the model customization methods for Bedrock? So continued pre-training uses unlabeled data to pre-train a model, whereas fine-tuning uses labeled data to train a model. Okay, so yeah, so Bedrock has two model customization techniques, right? There's pre-training, which uses unlabeled data to improve the model's understanding of specific domain content. So it enhances like general knowledge of the model using raw documents, think like legal contracts or journals or something along those lines, right? And the model will learn context representations without knowing the specific output, the specific like expected output. And then labeled data would teach the model to perform specific tasks, right? Like the classification, the summarization. And then with the fine tuning, the model can be updated using example input output pairs, right? So pre-training would involve something like putting 10,000 research papers on like oncology. And then the fine tuning would involve label question and answer pairs to train the model to answer cancer related questions accurately. All right. All right. So that would help that. And why are the other ones incorrect? Pre-training uses unlabeled. Okay. So fine tuning requires label data to map inputs to correct outputs. So it's a supervised learning process. And then pre-training uses label data to pre-train a model and fine-tuning. Okay, so this is incorrect because only fine-tuning uses label data. Pre-training relies on unlabeled data to improve foundational understanding. And then pre-training uses labeled data to train a model, whereas fine-tuning. Okay, so this reverses the correct definition. So pre-training, unlabeled. Fine-tuning, labeled. All right. Okay, which of the following aptly summarizes the way transformer models work? Okay, so transformer models use a self-attention mechanism and implement contextual embeddings. What does that mean? All right, why is that correct? So transformer models are neural network architects, right? Architectures. So these are introduced way back, um, 2015, 2017. So they're used in Gen AI and LLMs like ChatGPT, Claude, whatever, right? So these have a couple of different characteristics like self-attention, right? So each word in the input can attend to all other words. So it lets the model capture the relationships regardless of the position. Um, Contextual. So there's context, right? So the context has embedded change based on the context, right? So something like the word bank would mean different things in a sentence. Like something when you're saying when you have a sentence with like a riverbank versus a commercial financial bank. Same word, different context, and it can understand that. And then positional encoding. So since transformers process input in parallel, they use positional encoding to understand word order. All right. So this means that transformers are really effective for LLMs for like translations, for text summaries, or any questions to answer. All right. So it can get pretty close with effective thinking. So why the other one's incorrect? Transformer models learn by learning a compact representation of data. Okay. So this describes variational encoders. So this is like when this VAE this encodes data into a latent space to perform generation or reconstruction tasks. Right? So think of it as like error correcting or remediation within it. So transformer models create new data by okay. So this is this sounds like diffusion. So like diffusion does that denoising and noising of data to generate new data. Okay. And then transformer models work by training two neural networks. And okay, so this describes GAN. Um, so this is the generator and the discriminator. So this is trained in opposition. Okay. All right. Next question. What is the key difference between foundation models and large language models in context of Gen AI? All right. So foundation models serve as a broad base for various AI applications by providing generalized capabilities, whereas large language models are specialized for understanding and generating human language. Okay, so why is this correct? So foundation models are large scale, right? So they're general models trained on massive data sets, like across domains, things like text, images, audio, code, whatever, and can be adapted for a lot of downstream stuff like image classification, text generation, question answering, semantic search, all this, right? So it's like a general base for AI capabilities, and it can be customized with fine tuning, prompt engineering for specific applications, right? But LLMs are a specific type of foundation model. So they're specialized in natural language understanding and generation. So LLMs focus more on tasks like text summaries, question answering, sentiment analysis, language translation, conversational agents. So think of like LLMs as a subset of foundation models, and it focuses much more narrowly on language. All right, so why are the other ones? Okay, so large language models are pre-trained on massive data sets. It can be fine-tuned. Okay, so this is incorrect, right? So both foundation models or LLMs are pre-trained on massive data sets, right? No. So foundation models are not built from scratch per use case. So in fact, their purpose is reuse and adaptability across use cases. All right. And foundation models are specifically designed for text generation. All right, so this is reverse. So foundation models can span multiple modalities like text, images, videos, audios, right? But LLMs are text focused. Okay, so that they do a lot of that flipping and reversing. All right. Foundation models are only used in academics research. Well, okay. All right. It's incorrect. So both of these are used in academic and commercial settings, right? So just from the AWS basket, right? You have like Bedrock, you have Health, Comprehend, Q. These are all um, models in enterprise use cases. Okay. All right. Next question. Which of the following allows business analysts to use natural language to build business intelligence dashboards? All right, that's Q and QuickSight. Dashboards, QuickSight. Always remember that one. All right, so QuickSight is AWS's BI assistant, right? Or Q in QuickSight, right? So it lets businesses use natural language to create BI, business intelligence dashboards, visualizations, complex calculations, and it has executive summary capabilities. And you could do like data stories, right? So with the natural language prompt, you can ask questions of the data, generate shareable dashboards and insights, and get rid of the need for deep SQL or visualization knowledge. So very useful, but you should probably know some SQL. And then Q and Connect. So, okay, so Q, all right, so Connect is AWS's contact center service, like their call center, right? So it enhances like real-time agent assistance, like what to say, actions to take during like a customer interaction. So it's not for dashboarding. Q Developer, this is for software developers and IT pros. So it helps with code generation, bug fixing, optimization, but not business intelligence visualizations. I think Q Business is that's just a general purpose AI assistant for cases like IT help desk, HR, internal search, right? So it doesn't build BI dashboards, but it can provide chat like questions in enterprises, right? So it's like in the toolbox of a business solution, but it's not really for that. No. Okay. Next question. Oops. How does reinforcement learning work? So reinforcement learning involves an agent interacting with the environment by taking actions and receiving rewards or penalties, learning a policy to maximize cumulative rewards over time. Okay, so reinforcement learning is a type of machine learning where an agent interacts with the environment, then it takes actions, receives feedback, gets rewards or penalties. The goal for it, though, is to learn a policy that maximizes the rewards, right? So this is like a trial and error learning process. So it's suited for tasks like robotics, games, decision making, okay? So let's see the other ones. Why the incorrect? So reinforcement learning relies on unsupervised learning techniques. Okay, so this describes unsupervised learning, right? Which is clustering. Okay, so this doesn't involve feedback like rewards or penalties. Remember, look for those keywords. So reinforcement learning requires feedback to improve, unlike cluster algorithms like k-means. Reinforcement learning uses supervised learning algorithms to label data. All right, so supervised learning uses labeled data sets to predict outcomes, right? So reinforcement learning is not label based. Reinforcement learning it learns from interaction and reward signals, not fixed data sets. And then reinforcement learning transforms raw data into new feature space to reduce. Okay, so this describes dimensionality reduction techniques like PCA. So reinforcement learning is forced on sequential decision making, not just data pre-processing or processing. All right. All right. Next question. Which SageMaker service will help understand how an input feature contributes to the predictions of a machine learning model? Clarify. All right. So Clarify helps with any machine learning practitioner. How do you understand how the input impacts the overall model predictions, right? So this is good for responsible AI and model explainability, right? So it helps you look at the graphs that it produces during training and inference. It helps with bias detection in the data and the models. It helps for explanations via the APIs for the individual predictions, right? And then it's integrated with SageMaker for visualizations. So it gives you like a post hoc explainability for any tabular or text-based models, and it aligns with the best practices with responsible AI. Okay, why are the other ones incorrect? Okay, so SageMaker Canvas. Okay, that's a no-code tool for building machine learning models, right? That's like a easy one. So it's not focused on feature attribution or model interpretability. SageMaker Ground Truth. So this is good for data labeling and humans in the loop of data annotation, but it doesn't provide any insights or for the feature influence or predictions, right? And then SageMaker Jumpstart. This launches pre-trained models and provides starter solutions, not model interpretation. So it works more with like model deployment and fine tuning. It's not interpretability, that's what Clarify is about. It's in the name. Okay. Next question. A company wants to use Bedrock for a use case that involves generating images from text prompts. Which of the following models do you recommend? Stable Diffusion. Okay. So Stable Diffusion is a text to image generation AI model, right? So it can convert natural language prompts into photorealistic images. It can do other illustrations, artwork, whatever. So this makes it the best model based on what the question's asking, especially for generating images from text prompts. And you can find this in Bedrock. And yeah, I think it's just Bedrock. Okay. But why are the other ones incorrect? Okay, so Jurassic, I think, is an LLM, not an image generator. But I just I'll say this: I know Stable Diffusion is an image generator. You should recognize that. Okay, then Llama. That's a Facebook model, right? Or meta model. That's a that's a language model. That's for text understanding and generation. So it's not capable of producing images. And then Claude is an LLM for text tasks like summarization, code generation, and you could do some multilingual conversation. So it can't make visual output like images. Uh, Next question. Okay. How does the inference parameter top P influence the model response for Bedrock? All right. So this influences the percentage of most likely candidates that the model considers for the next token. All right. So what does this mean? Top P is an inference parameter used in sampling. Okay. So it sets a probability threshold, right? The model selects for the smallest set of tokens whose probability exceeds the threshold. So for an example, if you had a top P equals 0.9, this means the model will sample from the smallest set of tokens whose combined probability is at least 90%. All right. So when you look at this, a lower top P, like 0.1, narrows the pool. So it's more deterministic. And then a higher top P broadens the pool, makes it more diverse and creative. Okay. So why are the other ones incorrect? So influences the likelihood of the model selecting lower probability. Okay, so this describes the temperature parameter. Temperature controls randomness, right? Where with temperature, 0 would be much more deterministic. So it's kind of similar in the determinism, but it's for different things, right? So temperature, the randomness as opposed to the probability. All right, these are different ones. Okay, and the one is the maximum creativity. And then specifies a sequence of characters to stop. Okay, that's the stop sequences. So this is if the model outputs any defined stop string. So its generation will halt it immediately. Okay, and then influences the number of most likely candidates as the model continues. So this is actually top K. All right. Okay, so with top K, the model selects from the most likely tokens, like a fixed number. Whereas top P looks for the percentage. That would usually help, number versus percentage, right? But all right, so top K looks for the most likely tokens, and then top P would select from the probability threshold, right? So the K helps you for the likely amount of tokens to solve that problem. P would give you whether or not you want that problem to be more deterministic or more creative. All right. Next question. Okay. The marketing marketing department at a media company wants to leverage Bedrock for making creative scripts for an upcoming ad campaign. What do you recommend? Use higher temperature to get more creative responses for the same prompt on Bedrock. Okay, so we've covered this. Temperature in Bedrock controls response creativity and randomness, right? So a lower temperature, let's say 0. Okay, let's say 0. Jeez Louise. Okay, jeez Louise, come on. Sorry about that. All right, so 0 would be more deterministic. All right. Whereas 1 would be creative / random. All right. So this is ideal for cases like script writing, storytelling, ideation, or other marketing tasks, right? Which is what the question is asking for. Remember that marketing department. You want creativity aligned with the values. Okay. All right, why are the other ones incorrect? All right, so higher top P to get more creative. Okay, so top P is the size of the candidate pool. Okay, so top P can make a broad output range, more choices. It's not the primary driver of creativity. It's more about diversity in the sampling, not the randomness. All right. And then a lower temperature, well, this is not what you want. So a lower temperature makes it more predictable, less creative. So the goal for a creative variety or creative, output, without being repetitive, this would actually be against the answer. And then lower top P. Okay, so top P would shrink the pool of possible token candidates. So it would make output more deterministic, not more creative. Okay. Okay. All right. Next question. All right. You're an LLM developer at a company. The company wants to migrate to AWS. Which AWS services would you recommend for developing LLMs? Bedrock, SageMaker, Jumpstart. All right. So Bedrock is the managed service to build and scale Gen AI applications using foundation models, including LLMs. So this will give you access to models like from Anthropic, um, Amazon, Meta, etc. And so this will let you customize and orchestrate the LLM without managing the infrastructure. And then SageMaker Jumpstart. So that's a hub in SageMaker to deploy pre-trained foundation models, including LLMs, with just a few clicks. Okay. And then this will have like customization tools for user interfaces or SDKs. And then it's good for developers and researchers who need out-of-the-box model access. All right, so why are the other ones incorrect? So Inferentia, this is a custom chip for inference acceleration, not LLM development or training, right? So it's good for deploying already trained models in cost-efficient workloads. And then Trainium, that's designed for deep learning model training. So it's good for custom model training at scale. So it's powerful, but it's hardware. It's not a platform service like Bedrock or Jumpstart, right? So think about the question, what is the answer is going to be? And then Q, that's a Gen AI assistant for developers with code generation. So it's not for LLM development itself. It can use them, but it's not a tool for developing or training LLMs. All right. All right. So that's where we're going to stop for today. All right. So we went over about 30 questions. I think you should enjoy this. We're going to come back and give you another round of those. I have a lot more to go through. But before we sign off, remember, click the like button, subscribe, leave a comment, and recommend it to anybody you know who's taking the AWS AI Practitioner exam. Anyways, thank you for joining me and have a good day.